Welcome to Sweet Life Beat Life. We hope this video helps.
You start by preparing a reproducible environment. Install Python 3, 10 or later, and a quantum SDK like Qiskit or Circ so you can run circuits locally. Once done, register for a cloud backend and copy your API key to a secure file. Make sure to load it into your code at runtime. You should also review qubit primitives, superposition and entanglement, and common gates like X, H, and C0 so you understand why circuits behave the way they do. You now build a first working circuit. Initialize qubits, apply an H gate to create superposition, then a C0 to entangle, and finish with measurement. Run that on a simulator to check state vector and measurement counts. Simulators let you iterate quickly and find logical bugs. Once you have a clean result, introduce realistic noise models and calibrate circuit depth to see how fidelity degrades. This explains why shallower circuits often perform better on current hardware. You deploy to cloud hardware by selecting a device with enough qubits and the lowest error rates. Submit your transpiled circuit and await job results. Once done, analyze counts and compare against the simulator to identify disparities and make sure to optimize. Transpile for the target topology, reduce depth, and remap qubits to avoid extra swap. If results look wrong, check device calibration and noise. Retry with error mitigation or simpler circuits. This single trouble.
Thanks for watching. Consider subscribing if we helped you.